Still loading. Okay. So now let us see how to solve these questions. So it's a electric force questions. 3-point charges lie along the axis as shown in figure below. So you have Q1, Q2, Q3. Questions A, sketch electric force diagram on Q2. So our main focus, our object in this question is Q2, right? So which means the force diagram that we want to sketch is the diagram for Q2. So do we need to sketch the diagram for Q1 and Q3 then? No, we don't need. Why? Because question just asks us to focus on Q2. And since this is an electric force diagram question, so you need to know how to determine the directions of the force acting on Q2. So how? When it comes to force, remember, you need to check the relationship between two charges. You want to see what happens between Q1 and Q2 and also between Q2 and Q3, right? So you cannot determine the directions of the force based on just one charge, okay? Solely based on just one charge. Cannot. You need to look at two charges. You need to look at it, whether there's an attractive force between them or there's a repulsive force between them. So now let's see. Q1, Q2, both of them, they are positive charge. So if they are positive charges, then they will repel each other, which means the force acting on Q2 will be heading to the right hand side. Okay, it will be heading to the right hand side. So this is F12. So done. Okay, so do you have to sketch a diagram for Q1? Well, it's up to you in this diagram, in the original diagram. But when it comes to questions 1, you just want the diagram for Q2. All right, remember? So Q1, if you want to draw it here, oh well, also can, nothing's wrong. So F21. Then how about Q2 and Q3? What is the relationship between Q2 and Q3? Once again, both of them, they are positive charges. So if they are positive charges, means there will be a repulsive force between them. So repel, you have F32 here, and this would be F23. So what am I going to do next? I'm just going to transfer this diagram into questions A, right? So questions A, I have positive charge here, Q2, and then here is F32, and the other directions is F12. Done. That is the answer for questions A, right? So you just focus on what happens on Q2 because that is the object in this question, right? That is the object in these questions. So questions B, calculate the magnitude and direction. So you need to determine both things in questions B of the total force exerted on Q2. So once again, we're going to focus on what happens on Q2. So remember, the way we calculate resultant force in this chapter is same as what we have been doing in SEM 1. Okay, but there's an additional step here in which you have to calculate F32 and F12 first before you proceed to resolving vector and resultant vector. So F12 is equals to KQ1 Q2 over R12 square, and then F32 is equals to KQ2 Q3 over R23 square. So you calculate, you obtain the value before you proceed to resolving and resultant vector. Okay, now let us look at the diagram again. If you look at this diagram, the diagram in questions A, now both vectors, they are lying on the same plane. They are lying on the same axis, which means you don't have to do resolving vector in this case. All right, what you have to do, you just have to take into considerations their directions in your solution. So since I want to calculate the force exerted on Q2, so summations F2 is equals to, now according to my diagram, F32 is going to the left-hand side. In vector, if your vector is pointing to the left-hand side, we assume it is a negative value. So negative F32 plus, now F12 is heading to the right-hand side, so it is a positive value. Therefore, I'm just going to write it as F12. So negative 32 plus F12, so equals to, now you plug in the value, and then you calculate the answer. right? So if you do it correctly, you should obtain a negative 6 times 10 to the power of 12 Newton. So whenever you obtain a negative value, remember, okay, always change it into a statement form. All right, always change it into a statement form, because magnitude is a value without a negative sign, and directions, well, you describe it. Okay, you describe it. So the resultant force, the force on Q2, okay, force on Q2 is 6 times 10 to the power of 12 Newton. Well, negative means it is to the left. Okay, to the left. So force acting on Q2 is 6 times 10 to the power of 12 Newton to the left. Change it into a statement form. Alright, remember, whenever you have a negative value, you rewrite it in the statement form. Alright, now question C. Question C is the ones that we have tried in example 4. Okay, so it asks you to determine the positions of Q2 from Q1 if the total force is 0. Aha. So again, we are still going to use the same diagram. All right, we have a charge Q3 right here, and then this is Q2, and then this is Q1. All right, and then the distance, okay, the distance between the 1 and 3 is still 8 cm. All right, we didn't change anything between the 1 and 3. It is still 8 cm. The ones that we change is the positions of Q2. All right. Now we move Q2 until the net force acting on it is equals to 0. And we don't know. Okay, we don't know what is the value. All right, we don't know what is the value. Yeah, I made a mistake here. This one is Q3. This one is Q1. This one is Q3. All right, now we didn't change anything. We just moved Q2 until the total force acting on it is 0. And what we want to determine is the distance of Q2 from Q1. All right. So the unknown is lying in between 1 and 2. So this one I'm going to label it as X. Then what should I label here? Okay, what should I label as a distance between Q2 and Q3? Remember, when we solve questions, good. 8 tolak X. When we solve questions, we want to reduce the amounts of unknown. So you don't label it as Y, you don't label it as Z. You label it as X, HCM minus X. All right, we try to reduce the unknown. Always keep that in your mind. When we solve questions, we don't want to generate too many unknown. We don't want to create more unknown. The more unknown you have, the harder it is. So we reduce the unknown by using 8 minus X rather than Y. Okay, so now that I have all of these, okay, and according to the questions, I know that summations F2 is now equals to 0. Okay, and also we know that summations F2 is equals to negative F32 plus F12. Because we didn't change the type of the charge, what we changed is just the positions of Q2. Therefore, the free body diagram is still the same, the force diagram is still the same. Rearrange the equations, we have F12 equals to F32. Expand the equations, we have KQ1Q2 over R12 square, KQ2Q3 over R23 square. Well, as usual, we remove the same value, the constant first. Okay, so Q2, you can also remove it. So you're left with Q1 over R12 square, and then Q3 over R23 square. Q1, Q3 is a known value. You have the value. R12 and R23 it is an unknown. You don't have the value. So what are you going to do? Remember, you don't expand the equation. You square root both sides. Okay, square root both sides. So when you square root both sides, what happens right here is actually now, if you square root A over B, it is square root A over square root B. So basically, you can remove the square in the equations. Right. If you do everything correctly, you should obtain x equals to 0.029 meter. So this is the final answer. Right? This is the final answer. So what I want you to do right now, I give you 2 minutes, Okay, I give you 2 minutes to tidy up your answer or to write it down if you couldn't get the answer, if you don't know how to solve it. Okay, so 2 minit untuk Anda catat. Kalau ada sebarang pertanyaan, ada apa-apa yang Anda tak faham, okay, sila tanya. Okay, so pastikan Anda bila Anda buat revisions, Anda tengok balik soalan ini dengan soalan example 4 so that you have a better idea what is the difference between force and field. Okay. So next, okay, I have one more. Oops, I have one more questions for you guys. So now let's look at questions number 2. So again, questions number 2. Now this question is very similar to your example 2. All right, example 2. So again, I'm going to give you 10 minutes to solve this question. See whether you can do it by yourself or not. Just remember, now you are looking at electric field strength. Okay, you are looking at electric field strength. You are not looking at force anymore. So how are you going to sketch electric field strength diagram in this case? Okay, sama juga bagi Anda 10 menit Anda cuba buat. So dalam exam itulah lebih kurang dia masa yang kamu kena guna untuk satu soalan. Jangan lebih. Okay, jangan lebih. All right. So now let us see how to sketch electric field diagram at point M. So you have 2 point charges. One is a negative 2 nanocoulomb and the other one is positive 3.2 nanocoulomb. So they are placed 3 cm apart as shown in the figure. Sketch electric field strength diagram at point M. So how are we going to sketch electric field or strength diagram at point M? If you remember, okay, when we look at the electric field, the directions of the electric field is being determined by the sign of the charge. If you have a negative charge, then the electric field is going inward. Okay, it is going inward. So what does it mean by it's going inward? It is going moving towards the charge. If you have a positive charge, then the directions of the field is moving outward.
Outward.
Hmm. So if it's moving outward, what does it mean? It means once again the directions of the field is now away from the charge. It tells us the direction. So now let us look at Q1 and M. Q1 is a negative charge. M is just a point. All right. When it comes to electric field, you don't need second charge. What you want is just a point, a position. It could be a charge. It could be just a point without anything. So in this case, you have a point M without anything. So you want to see what is the directions of electric field from Q1 at point M. Q1 negative, so the directions of the field should be pointing towards the charge. And this would be my E1M. It is pointing towards the charge because it is a negative charge. Then how about Q2? Q2 is a positive charge. When it comes to positive charge, we know that the direction should be away from the charge. So away from the charge means the direction would be going to the right hand side. So this is your E2M. So basically this is a complete diagram for my questions A. So questions A,
Madam,
I have point M. Yes.
if I do theta, boleh tak madam?
If you do what?
Theta.
Theta. Okay, you want to put the theta, of course you can because you need the theta anyway. Okay, but this question, questions A, because it hasn't asked you to calculate it yet. All right, so you can do it with or without the angle. But if you are given the angle, then you must show it in your diagram. Okay, so this is your theta. So this would be your E2M. And then here would be your E1M. Okay, your E1M. And then this is the angle. Okay, this is the angle. All right, so my next task, it asks you to determine the magnitude and directions of resultant electric field intensity at point M. So, well, like you mentioned just now, you need theta. So how to determine the theta? You look at this diagram. It is a right angle triangle. When you have right angle triangle, you can actually apply trigo functions to determine the value. Now you look at this diagram again. This is hypotenuse, this is opposite, this is adjacent. So you are given the values of the opposite and adjacent. You want to determine theta. Therefore, you can apply tangent to determine the angle. So tangent theta is equals to, now tangent is opposite over adjacent. So it is equals to 3 over 4. Okay, so theta equals to tangent -1, 3 over 4. So you should obtain, wait, yeah, let me see what is the values that you're going to get. You should get a value that is equals to 36.87. Okay, 36.87 degree. So that is the answer that you should get for the angle. So now that you have angles, you can then proceed to questions B. So questions B determines the magnitude and directions of resultant electric field. Well, if you look at the diagram in questions A, now you have two vectors that are pointing towards different direction and they are not lying on the same plane. If they are not lying on the same plane, you need to resolve it. But before resolving vector, always remember, you need to calculate the values of electric field first. So you calculate E1M by using KQ1 over R1M square, and then you calculate E2M by using KQ2 over R2M. All right, now remember, when it comes to using the equation for force, and electric field, you ignore negative sign in your calculation. Okay, ignore the negative sign for the charge. So which means even for a Q1, it is a negative charge, but you just plug in the positive value. You just plug in a value without the charge, okay, without the negative sign. So now that you have a EM1 and E1M and E2M, you can then proceed to resolving vector by using the table as usual. So this is the table. This is your X, this is your Y component. So E1M, E2M, and then next would be the total. Okay, so you need the total. So summation. So summations fx equals to summations fy equals to. So you find the summation before you proceed to resultant vector. And it's different than the previous step. When it comes to this table, you need to take into consideration, you need to include, okay, you need to include the sign. The sign for what? The sign for the direction. Okay, the sign for the direction. So just now you ignore the negative sign for the charge. Now you want to include the direction. Now what does it mean by include the direction? If you look at E1M, E1M, if we resolve it, you will get a Y component that is going up and an X component that is going to the left. So X component for E1M, it is a negative direction and Y component is a positive direction. When it comes to E2M, now E2M is lying on the X component and it is heading to the right hand side. Therefore, it is a positive direction. Well, since it's lying on the X component, the Y component is equal to 0. So that is the table. Okay, that is a sign convention that you're going to use in a table. So once that you have all this value, you can then proceed to resultant vector. So summations electric field at point M is equals to square root. Oh, it should be E, sorry, not F, yeah, E. So it's equals to square root summations E x square plus summations EY square, right? So once that you have the value, you can then calculate the direction. Now direction, when it comes to this question, you use theta m. Why? Now you cannot use theta anymore. Why? Because you have already used it in a previous calculation. You use theta here already. Okay. So the next one, the theta for the positions m, you need to add a subscript. Okay, to differentiate between the theta in the original questions in your diagram and the theta in the resultant value. Okay, the theta in the resultant value. So theta m, it is equals to tangent -1 modulus summations ey over summations ex. All right, so you should get a value that is equals to a 19.3 degree. Okay, so the resultant is 1.30 times 10 to the power of 4 NC negative 1. So once that you have the angle, remember you need to describe the position. So how are you going to describe? You look at the sign for the resultant for the summation EX and summations EY. Summation EX, if you got it right, you should get a positive value. Summations EY, you got it right, you should get another positive value. Positive, positive, it tells you that your resultant vector should be lying on the first quadrant. Okay, it should be in first quadrant. Therefore, 19.3 degree is located at above positive x-axis. So that is how you describe it. Okay, that is how you describe it. So done. Okay, done. That is a question. That is the answer for questions number 2. Okay, that is the question for question. That is the answer for question number two. So again, when you do revision, you try to compare with example two in your book. Okay, you try to compare with example two in your books so that you can see what is the difference between electric field and electric force. It is very important because students always get confused in the exam. They always use the wrong technique, wrong method to determine the directions of the vector. Okay, so when you do revisions, you do the comparison between questions 2 and example 2 in your books. So questions 1, you compare with example 4 so that you can see the difference. And that is the main reason why I show you these two questions today. All right? So again, I give you 2 minutes to solve this, okay, to write it down. After that, we will do one past year question. Okay, we will do one past year questions together. So 2 minit untuk Anda catat. Kalau Anda ada apa-apa tak faham, okay, atau tak dapat jawapan, okay, Anda boleh tanya. Okay, so now let us look at one past year questions together, the questions that you can actually do right now. So go to 2017, 2018. Okay, we're going to do these questions together. We're going to do it quickly in 5 minutes. Okay, so let's see. Now, previously, you have to memorize all the definitions, okay, all the definitions for your final exam. But now you don't have to memorize it anymore. Okay, so question 7A, it won't comes up in the final exam anymore. Okay, it will be a part of your UPS question. All right, so let us look at this question. Question 7B. Question 7B, you are given three charges. Why Q1 is a positive charge, and then Q2 is a negative charge, Q3 again it is a positive charge. So you have two positive charges and one negative charge in this question. Determine the magnitude and directions of the, well, you look at the question, of the force, okay, force on Q3. So the two keywords in this question is now you're looking at force, not field, okay, force, not field, and the object in this question is Q3. Okay, so Q3 is acting as our object in this question 7B. So first step, now, even though the question didn't ask you to sketch force diagram, but you need the force diagram to solve it. So you must show the force diagram. Okay, mark will be given to the diagram, even though it's not being mentioned in the question. So make sure you sketch the force diagram. Make it a habit. Okay, make it a habit because mark will be given even though it is not being asked. So Q3 is our main object. What am I going to do right now? I want to check the relationship between Q1 and Q3 and also the relationship between Q2 and Q3. So Q1 and Q3, both of them, they are positive, so which means they will repel each other. So if they repel each other, the directions of the force acting on Q3 will be going toward this direction. Aha. Okay, so this is a direction. All right. Sang it a bit. Uh, right. Okay, like this lah. So this is your F1 tree. Okay, the first acting on Q3 because of Q1. Okay, because of Q1. So from 1 on 3. Then next, I want to check the relationship between Q2 and Q3. So Q2 and Q3, one positive, one negative, means that there will be an attractive force between them. Okay, there will be an attractive force between them. So the direction would be like this. So this is F23. Okay, F23. So I can now sketch a free body diagram. So this is my charge Q number 3, and then this is the X component, this is the Y component. I have a force going up, which is F13, and I have a force heading towards here, which is F23. Now this question, okay, this diagram, you need to include the angle. Why? Because angle is being given. Okay, angle is being given. So what is the angles for F13? Now, if this is 72 degree, here would be 18 degree. So this is 18 degree. Okay, 18 degree. So here is a 56, which means that right here would be 34 degree. Okay, so 34 degree right here. So 18 and 34, you need to include it in your diagram. Okay, this one is easier because it's given. Straight away you can tell from the diagram given, okay, you have the angle, therefore you need to include it in your electric force diagram. All right, now that you have the free body diagram, you can then proceed to the calculation. So you can calculate F13 as usual by using KQ1 Q3 over R13 squared, and then F23 by using KQ2 Q3 over R23 squared. As usual, when it comes to the calculations of a force, you ignore, okay, you ignore the sign of the charge. Okay, you ignore the signs of the charge. So don't include the negative sign in your calculation. All right, you should obtain two positive value. So once that you have the force, okay, you can then proceed to resolving vector. So the reasons why I need a table, it is because now both vector, they are not lying on the same plane. Okay, they are not lying on the same plane. So I have a F13 here, I have a F23 right here, and then I'm going to resolve it. I'm going to resolve it and then calculate resultant. So summations fx, summations fy as usual. So once that you have these two values, you can then calculate the total force on charge 3. So square root summations fx squared plus summations fy squared. And then you calculate the angle. Okay, calculate the angle as usual. So summations fy over summations fx. All right. So that is how you solve it. Okay, that is how you solve these questions. So I give you the step, you complete the rest. Okay, you complete the rest. And you have the final answer in your books already. Okay, kamu sudah ada final answer, so kamu kira dan kamu buatlah, kamu kira dan kamu buat step yang lengkap di dalam buku Anda atau di dalam nota Anda. Okay, di dalam buku atau di dalam nota Anda. So that's all for today. You write it down. Okay, you write it down in your books. If you have any questions, you may ask. If no, that's all for today. You may leave the class.